Hey guys, let's talk about square roots, okay? So, first thing we're going to do is we are going to evaluate square roots of perfect squares. So, I also want to real quick tell you guys because, just in case you see me write square root and then of something, it'll be in parentheses, right? So like this 4a, that would be square root of 64. Okay, that's in case I have to put it like in a document and it doesn't have the square root symbol available to me. That's how I would write like 4a. That equals the square root of 64. Okay, I just want to say that so if you ever see it, then you know what that means. Okay, back to the fun stuff now. So number one, the inverse of squaring a number is finding its, square root. Okay. The number under the radical sign is called the radicand. So 64 would be the radicand here. Okay? True or false? A rational number is a perfect square if it is the square of a rational number. That is very true. So now let's look down here and let's do some of these. We've already used that. Don't want to be boring. Evaluate each square root. So the square root of 64, well, that's going to equal 8. The square root of 25 divided by 169, well, it's fair in math to break these apart. So if you have a big square root with a fraction underneath it, you could break it into two little square roots, which makes it much easier to see. So the square root of 25 is 5. The square root of 169 is 13. So that gives us 5/13. Okay. Now let's look at the next one. The square root of 0.25, well, that equals 0.5. And then, last but not least, pink, I guess, the square root of, the square of the square root of 14 is just 14. Now we're going to evaluate each of these expressions. So if we have 7 times the square root of 16, well, that's 7 times 4, which is 28. B, if we have the square root of 144 plus 25, well, that equals the square root of 169. We've already found that. That equals 13. Now we have the square root of 36 plus the square root of 81. Well, that's going to equal 6 plus 9, which is going to give us 15. This one we have to do by the order of operations, right? So we know we're going to leave our 25 where it is. I'm going to leave my minus sign there, so we're going to have 4 times 3 times a negative 2, which is going to give us a negative 24. Well, if we have the square root of 25 plus 24, that's all under the square root, then that's going to give us the square root of 49, which we know is 7. Okay, so it's really important to do your order of operations first, right? Multiplication first, then we do the addition or subtraction. Okay. So our next is to determine whether a square root is rational, irrational, or not a real number. So the question number 6 is, why is square root of 7 not a rational number? Well, and the reason for that is just because 7 is not a perfect square. Alright, for it to be a rational number, whatever your radicand has to be a perfect square, right? Like 9, or 4, or 16, or 25. Okay, number 7, true or false? The square root of a negative number is a real number. Please say false, because that is so not true, right? If you have a negative number under an even root, then that's going to give you an imaginary, right? Okay. Write a decimal approximation of each radical rounded to 2 decimal places. Very important there. All right, let's do this. So if we take the square root of 8, let's pull up our little I gotta get him down here. He's on my other monitors. There we go. Perfect. I say perfect. Let's get him up here. Whoa, not what I wanted. Where are we? Here. This is what I want. Let's try this again. Let's do this one more time. Okay. Perfect. Okay. So we want to do the square root of 8. We just do second above this square root. 8. Hit enter. That's where we see that it's going to be 2.83. It's going to be our answer here. Okay, so that's how we're going to do it for all of those. I'm not going to keep doing it. I'm just going to tell you what it is because I would have to jump back and forth. But this is approximately, right, because we are rounding, so we know we're going to put our wavy equal sign, so it's 2.83. Our next one, the square root of 91, is going to be approximately 9.54. And then the square root of 1200, I'm going to give you guys time to do it if you want to. It's going to be approximately 34.64. Okay. Now let's determine whether the square root is rational, irrational, or not a real number. It says evaluate each real square root that is rational. For each square root that is irrational, express the square root as a decimal rounded to 2 places. Okay, that's our instructions. So the square root of -9, well, we have a negative underneath the square root, so we know we automatically have to pull out an I, right? So if we pull out, let's just say that's going to equal I, square roots of 9, and we know that that's going to be 3I, right? So this is imaginary, which is definitely not real, right? He is not a real number. He falls into the imaginary realm complex. Okay, what about this one? The square root of 121. Well, this one equals 11, right? He's very real. And then what about square root of 83? We probably should do wavy because it's going to be 9.11. Okay, let's move to 10. Regardless of whether a in the square root of a squared is positive or negative, the result is always going to be a, okay? And then I think since I answered this, you should know whether this next one is true or false. Let's just look and see if you know. So true or false, the square root of a variable expression, what raised to the second power, is the absolute value of the variable expression. Well, this right here says it's positive or negative. The result's always positive, so that would be true, right? It's always going to be the absolute value, which guarantees it to be positive. So with that said, let's answer the following. Evaluate each square root. So if we have the square root of -17 squared, our answer is going to be a positive, right? Absolute value. So it's going to be 17. The square root of 3 squared is going to be positive, which is 3. What about if we have absolute value, or that's not the absolute value, good grief, the square root of y squared? I gave the answer away, huh? It's going to be the absolute value of y, right? We can't just write y like we did 17 and 3 because we knew these were positive numbers. We don't know what y is, so we always have to put absolute value, right? Because what if it's like a -4, right? We have to put absolute values. So if we have the square root of 2x plus 5 squared, our answer is going to be absolute value of 2x plus 5. Okay, see the pattern? Now we have the square root of y squared minus 8y plus 16. So our answer here is going to be absolute value y squared minus 8y plus 16. But we're not done, right? We could factor this simply. We know there's y squared, so there's 2 y's. Factors of 16 that are going to add to give us negative 8, so that's going to be negative 4 and negative 4. We could write this even more simply just as absolute value of y minus 4, right? Because there's 2 of them, so let's just, write them once. I guess technically you really wouldn't even have to have your parentheses there. You could just do absolute value of y minus 4. Okay, that's my part. I'm going to leave it with you guys to do your part, and I hope